And now, next one is going to be, well, the other vector we want to concatenate to that vector of predicted profits, which is the vector of real profits. All right, so here we can do this very efficiently because this is exactly the same trick. I'm going to copy all this and paste that here and just replace ypred by, what do we have to replace ypred by? Well, of course, we have to replace it by ytest, because ytest contains, of course, the real profit in the test set. All right, here we are evaluating our model on the test set. So here we go, replacing ypred by ytest, and here as well, actually we could keep that because the length of ytest is the same as the length of ypred. But there we go. Now we have a beautiful concatenation of two vertical vectors. But remember this, this up to here is actually the first argument of the concatenate function, and therefore we need to add the second one, which is the axis, as you can see. So axis here can take two values, 0 or 1. 0 means that we want to do a vertical concatenation, and 1 means that we want to do a horizontal concatenation. And since here we want to concatenate two vertical vectors together, well, that concatenation is actually horizontal, and therefore we have to input here axis equals 1. And we don't have to specify the name of the argument because this is input in the same order. All right, okay, good. So now we're going to observe the final result and see if our model was able to return some predictions, some predicted profits close to the real profits. So there we go. Let's press play to run the cell, and awesome! I didn't make any mistake. Perfect. So let's recap. We can clearly see that we have two vectors here. That's the first one and that's the second one. On the left we have the vector of predicted profits, so that's ypred, and on the right we have the vector of real profits for, of course, the 10 startups of the test set. All right, and so let's see what we get. Let's see if our predicted profits are close to the real profit. So for the first startup of the test set, well, the predicted profit is around 103,000 and the real profit is actually 103,200. So very close. That's perfect. That's an amazing first prediction. Then second startup of the test set, the predicted profit is 132,582 and the real profit is actually 144,000. So not a great prediction like before, but still not too bad. Third startup, 132, 146. Still not great, but not too bad either. Fourth startup, 71, actually 72, and 78. All right, so pretty close. Then 178, 191, okay. 116, 105. So actually the first prediction was amazing, but then, the other ones are still quite good. Then 67, 68, actually 81, okay. 98,000 and 97,000, very good. 113,000, actually 114,000, 110,000, very, very good. And 167,000 and 166,000, amazing predictions. So we have some, amazing predictions, very close to the real profits, and some okay predictions, okay-ish, that are not too far from the real results. So here, from what we see, well, we could say that the multiple linear regression is well adapted to this dataset. The dataset does not necessarily have some perfect linear correlations. However, you can be assured that with this linear regression class, well, it was able to select the right features with the right parameters to make these predictions. And even if you tune your linear regression model by, for example, applying backward elimination to select, a team of more statistically significant features, you will actually get similar results. You can try that, actually would be a good practice. We actually do that in the R section, but in terms of performance, this won't change much. And remember, your goal is to be efficient when building and testing your machine learning models. So when you get such results with your multiple linear regression, in real life, you will actually try other models. You will actually try other modules which can tune also, and then in the end you will compare the performance of each of these models and select the best one. So we'll talk about this again at the end of this section, and also a lot in part 10 on model selection. And so now I have to say congratulations, because you now know how to build another machine learning model, which is multiple linear regression, and therefore which you can add in your toolkit thanks to this new code template. Perfect. So now we're going to move on to R. I remind that you don't have to master the 2 programming languages. If you want to master the 2, that's fine. Join me in the R tutorials. And otherwise, if you want to stick to Python, well, feel free to skip the R section and join us, Kirill and I, in the next section on polynomial regression, where you will learn how to make predictions on a non-linear dataset, on a dataset with non-linear relationships, therefore with which a multiple linear regression model would not be relevant. So it's an absolutely necessary model to add in your toolkit, and you will add it in the next section. Until then, enjoy machine learning.